Good morning, everyone, or evening, depending on where you may be. So welcome to October. Guess it was October yesterday for those who tuned in to yesterday's short little video. So today we're going to kind of be going a bit slower. We're going to be doing a couple things that I haven't experimented much with in Elm yet. One of those is going to be fuzz testing, as they've been calling it in Elm. You may also be familiar with the term property testing or quick check. It's a way to kind of define some assertions that will be applied over a generated set of random data. So it's kind of an interesting approach to testing. We're going to be trying to use that to a useful purpose today. And let's see, the other thing, just random data generation in general. I've played with it a little bit, but I have not really done a lot of work with it in Elm. And for our project today, we're probably going to need to do some fancy, sophisticated things with random generation, depending on how far we get. So, I am expecting that we may not get to a super finished product by the end of today, but hopefully we'll learn a lot. And a lot of people have commented that as new Elm developers, it's been really useful for them to kind of see my thought process as I go through things. So you may get to see a lot of that today. So hopefully it will be a good use of your time if you're watching, and you can follow along. And if you're watching on YouTube, feel free to jump throughout. All right, so before we get started, though, I did want to talk about one thing, which is dealing with uneducated people on Twitter. So, as some of you may know, I am one of the organizers of a new event called Elm Bridge, which we're hosting the first one in San Francisco. It's free programming workshops focused on improving diversity in the Elm community by making a welcoming space for women and people of color and LGBTQ people. So, we just posted our event last week, and as a result of that, I've kind of been engaged a lot more on Twitter and dealing with people who, in some cases, are, I guess, against the idea of equality. That's kind of rare, but in most cases, people are just maybe defensive. They feel like they're getting attacked, or they just don't know much about the issue or the perspectives of women and people of color. So I wanted to give a couple tips to people in case you find yourself having to deal with that or even noticing it. So let's see. So I tend to think of it in a couple categories. The first category is people, or in a lot of cases there are bots out there on Twitter that are just trying to promote negative comments and be, I guess, incendiary or rile people up. You see stuff like that. If there's a lot of times what you'll see is a Twitter account with a sexually provocative avatar, and it's maybe just making a random comment that doesn't appear to be related to anything. In other cases, it's writing really nasty comments in response to people. You see stuff like that, just go report it. Don't even think twice about it, because you may think it doesn't involve you. In a lot of cases it doesn't, but it'll help out the people who are the target of that harassment if you just report that kind of stuff when you see it. For real people who are on Twitter and maybe just aren't educated, a site I like to use a lot is called the Geek Feminism Wiki. This link. So this is a great resource. So a standard approach I use if someone is making some racist or sexist comment. I guess for the Geek Feminism Wiki, it's generally more about sexist remarks. You can generally, on almost any topic, you can find a page on this wiki under this issues section. There are a lot of specific things about different ways that that sexism is perpetuated. So almost any sexist comment you see on Twitter will fall into one of these categories. It's a lot of interesting reading in here as well. So for example, one that I found the other day was an example of reverse sexism. So they have a nice page about it, explains what it is. In this case, it's when you're talking about equality and someone comes back and says, hey, what about men? By promoting women, you're being sexist against men. So here's a page that kind of talks about the perspective, why people think that, examples of it, why it's not a real thing, and how to combat that. So what I try to do on Twitter or YouTube comments or wherever I see it, the plan of attack is generally identify the issue, find a good link, send them the link to the page, and then just back out of the conversation at that point. If they keep replying and seem to be interested in learning, feel free to have a nice short conversation. But if they start pushing back, it's usually best to just mute them at that point. So yeah, that is my quick guide, I guess, to dealing with sexists on Twitter. If you are in a position of privilege, or realize that you have a lot more emotional resources and don't really have to deal with the personal confrontation of these issues that much. So if you are in a position of privilege, use that extra emotional energy you have to help defend other people. Oh yeah, and if you do reply to some uneducated person about an issue, you should remove the @ mention of the original person that they were replying to, so that the original person who is getting targeted doesn't have to deal with all the retweets and follows and any backlash that may come out of it. All right, so on to the Elm code. So the link in the bottom right corner was also up during the pre-show scene. So if any of you have checked that out already, great. There's a bit of code there already. So if you're following along, you should go and clone that repository right away. So let's start this up, and I'll show you what we've got here. Basically, we have some basic map rendering already in place, so we don't have to deal with that today. We can jump right to the map generation part and the testing. All right. So let's start up. So something someone mentioned in the last week's stream was this build tool, coincidentally also called ElmLive. And it's actually a great live reloading development server for Elm projects. So I'm going to go ahead and install that. This font a little larger. So in this project, I'm just going to say npm install elm-live. This is not my, this ElmLive is not my project, but it is a great, and I'll say that often when people suggest tools to me, I'm hesitant about them because I don't want to add a lot of extra steps or require knowledge of npm, for instance, or other command line tools. But in this case, all you do is npm install ElmLive, and then you have to know how to run it. So for me, I've installed it into node modules /bin/elmlive, and then you just give it the name of your Elm file, or your main Elm file, in my case main.elm. And okay, it's going to download all the dependencies first. And it starts up a development server. I'm going to start that up over here. And here's the project. So what ElmLive does that's different from Elm Reactor is that whenever I save a project, whenever I save any of the Elm files in my project, without me even going to the browser, it's automatically going to refresh for me. So I'm going to here change this water tile to desert, save the file, and it immediately just rebuilds and refreshes the page without me even having to switch over to the browser. So it's really great. The only thing you have to know is when you do an npm install where the binaries are in case it's not on your path. But other than that, it's really easy to set up. So I'm going to be using that for the rest of the day. All right, so let's take a look at what we have here. So we have a main file, and this main file is set up with two things. And let's actually add the annotation here. This view function, we give it two functions. The first function takes a point, which is an XY coordinate, and returns a tile, which is a record that has a string describing what should be on that tile. And then we give it a second function, which is a tile set. And this takes a tile, or excuse me, actually takes a string, I believe, which is the name of the thing on the tile, and is going to return an HTML message. So this essentially, the tile set does the rendering of a single tile. Then we get back HTML message. Cool. So this function, all it does is loop through a grid of 10 by 10, it loops through 10 rows, and then in each row it loops through 10 columns. And for each one of those, it calls this first function. I'm actually going to rename this to be called map. It uses the map to figure out what tile is at that point, and then it uses the tile set to figure out how to render that tile. So then the tile sets, I've actually got two of them. First one is this Gervais tile set, which is using these great Creative Commons attribution licensed tile sets. Let me just show you the website for this real quick. So in the tile library here, you can see there's all kinds of nice little tiles, tons and tons of stuff. So I've downloaded a few of the files, like these dungeon tiles, special tiles, land tiles, and extra town tiles. So in this tile set, we're using the sprite helper, which I'll show in a second. And here is the core tile function. So here's a list of all the different tile types that this one can handle, and then it just maps it to one of the files and a particular sprite addressed by coordinates inside of there. So I've got like different colors of desert, walls, ice, mountains, water, trees, other things like that. And then as a fallback, it uses this other tile set. This is called schematic, and all it does is just print the name of the thing. So as an example, if I put like question marks for this tile set, actually that kind of broke the layout. Okay, I guess the schematic tile set has some HTML problems. So forget about that one. We will stick to the Gervais tile sets for today. But the idea was there'd be a fallback, so if you didn't have an image for a tile yet, you could still use it in your map, but looks like that still has some bugs. Then the final file is the sprite file, which has some helpers where you can basically give it an image file name and some coordinates of where in that sprite file and how big the sprites in that file are, and then it'll automatically create an HTML div with a background image that's clipped to the right portion. Let's see, and Arkham in chat is asking if I can show where we're using the view function. Okay, so I assume you're talking about this view function in the main file. So that's referred to in main itself. So here we're calling view, and here I'm just inline creating a function that takes the XY record and produces the map. So here, there's just kind of a random expression. Actually, let's add this. We'll say if x plus y equals 6, oh, I see. Do a case of x and y. In the case of 6, we'll show a desert. In the case of 7, we'll show dark desert. I think that's the name of one of my tiles. Yep, there we go. And as a fallback, we show grass. So here I'm just using an anonymous function, but this is actually what we're going to be implementing is the map generation today. And then this last one, the tile function from the tile set, is the function that takes the name of the tile and renders it. All right, so what I'd like to do is define a map generation. So I want to try making the map for a town, in this case, not a map of like an overall world, but I'd like to focus on trying to make a town. So what I want to start with is getting our test framework set up, and then see if we can figure out how to set up a basic property test. And I think maybe a first test that we can write is to make sure that a town that's generated has some grass in it and has some roads in it. And that'll be kind of a very simplistic test, but I think it'll let us try out setting up the fuzz testing or the property testing and kind of get that all set up and see how it works and start writing a very basic algorithm. And then we can try to come up with some more sophisticated properties that can enforce things about the town to try to make it look like a nice town and just not a random mess of tiles scattered around. All right, so to start out, I'm going to go look at the documentation for elmtest, which is this one. Elm Community elmtest is the one we want. So here are 3 example tests, and we want to look for what they're calling fuzz tests. So let's see, this first test is a unit test. They're expecting the palindrome to equal the reverse of the palindrome. Okay, so that's testing one specific example. Here, they're doing basically the same thing, just using the pipeline operator. And okay, so here's a fuzz test. I think this is a keyword in the elmtest, or excuse me, a function coming from elmtest. This, I believe, is a random generator, then the test name, and then we give it a function that takes the generated random value and does something with it and does an expectation. Okay, so that's actually quite similar to a normal test. We just have to provide a random generator and have a parameter in the function. And yeah, in chat, people are asking why I'm not using html.app.program. And that's because there's nothing interactive at the moment. All I'm doing is rendering. So in this case, the type of main is actually HTML message. You only need a program if you are actually having interactive things, which I don't think we will today. Or if we do, we might have something where you can like click a button to regenerate a map. But until we get to that point, we won't need a program. All right, so before we can write a fuzz test, we need to actually have elmtest running. So they're suggesting that we do npm install -g elmtest. And personally, I like to just install things locally, the folder, rather than globally. I'm just going to say npm install elm-test. I'll spell install correctly. I'm doing basically what they recommend, just without the -g. Maybe not a good idea, because then it doesn't get put on my path, but I'm going to go with that for today. So since I didn't use -g, that's installed into the node modules folder here. And in the .bin folder, here is the elmtest binary that was installed from that npm package. Okay, cd into the folder that has my elm package. I have done that. Run elmtest init. Okay, so since elmtest is in this folder, in my node modules, I'm going to run it from there. .bin elmtest init. Okay, and it looks like it created a bunch of stuff for me. Copy all the dependencies into test dependency. Okay. So I don't think I have any such dependencies, or any extra dependencies other than default. I'm going to skip step 4 for the moment, and if we run into problems, I am confident we can diagnose them. So then let's just run elmtest. See what happens. All right, so one of my Atom plugins, elmjutsu goes crazy whenever you install new stuff. All right, so we ran 3 tests. It in fact tells us the random seed that it just used in case we want to exactly reproduce a particular test run that happens to use randomness. And we have one failing test, so let's look at test files. In test, here's main. Okay, this just looks like a boilerplate test runner. A tests file. Okay, here's the test suite that it generated for us. Testing addition, string left, and this test should fail. Okay, if we comment this one out, we should see all our tests pass. Cool, and we do. All right, so since we're going to be running tests in the terminal, I'm going to start a new tab up, have the ElmLive dev server running in the other tab. Again, I'll run out of the node modules folder. All right, refresh this. Cool. All right. So let's define our first test. This is going to be town map generation. Don't need any of this stuff. So we want to write a fuzz test. And to start with, we'll need a random generator. Maybe we can start with a normal unit test first and convert it to a fuzz test after that. Let's try that out. So, map contains some grass. Then the expect package. Let's take a look at what's in the expect package, or excuse me, the expect module. Okay, so we've got all this stuff. All right. So we're going to import expect. Okay, they've already imported it for us. So there's a basic test. That should pass. And it does. All right. So what do we want to do? We want to create a random map. And then that basically gives us a function. If you remember, our map is essentially this function. No, it's this function. The function that takes points and gives back tiles. So maybe what we can do is have a helper function that will convert map to a dictionary. So here's what I'm thinking for that. This is going to be a function that takes our map type. Remember, our map is going to be a function that takes a point and gives a tile. And if we want to turn that into dictionary, actually we don't really even need to do that. Let's turn it into a list. So this will just grab all of the tiles out of a particular region of the map. And we'll write that in a minute. And point and tile. I'm going to copy the types for now over here. Not sure where the best place to put those is. We're going to create a random map, get all the tiles, then list.any. We want to check if the tile of that location, I guess this is a little confusing. We have our tile object and our tile string. Maybe we can just simplify this for today's purposes. Just have type alias just be a string rather than record. Okay, so we'll create our map. Well, that's our ultimate goal. Convert the map into a list of tiles. Then check and see if any of the tiles have grass in it, and we'll expect that to be true. Expect.true. There we go. All right. So we're going to need to write this function, and this, I think we want to loop through some particular coordinate space. What I'd like to try for the moment is just to have all maps be a 10 by 10 square. We could easily parameterize that later if we wanted to. And actually, now that I'm thinking about this, it seems like a bit convoluted. I'm wondering if, rather than converting into a list, why don't we just try making a map.any And we can implement any directly for our map type. So rather than this, we're going to have map.any. Let's make a new module for that. Call it map.elm, module map, exposing any. Any is going to take a map, which, as we've been saying, is a function that takes a point and returns a tile. Okay, so this map module seems like a good place for the point tile types to live. So that's going to be the second argument. The first argument for any is going to be a function that takes a tile and gives back a bool. And this will return true if any of the tiles in the map match this predicate. Cool. All right. So how do we implement this? Maybe we should write some tests for the map first. So let's comment that out first. Let's make our map test. Map test is going to be describe map module. We're going to test any. Here's our basic test. Run that and that fail. Okay, can't find the map module. I think they want it now to live in this source folder. Try putting it there. And it doesn't like something about the map. Oh, okay. And it's tests not expose all. Okay. So all now going to be a test. We want it to contain the other tests. So that's going to contain the map test. And let's see, what did I do wrong here? Oh, I didn't put all equals. There we go. Let's see how that works. Okay. This test is failing. So here's what we want to do. Map.any, given a particular map that always returns the grass tile. And so this is our map. And our predicate is going to be always returning false. And we're going to expect that to be false. What did I do wrong here? The right argument is expecting bool to A. Okay, it looks like we have to pass a string to expect.false. Let's check that. Yeah, okay, great. Expected any return false. All right. There's our basic test case. Now let's write a test case for when one of the points returns true. Or I guess we can do when all points return true. This will be the same. And now we expect this to be true. All right, so now we should have a failing test. Great. And all right, so what's the simplest way to implement this? We can check our, let's see. So I think we want to call map by passing it an x and a y. So we want to start with x and y equal to 0. So this will give us the tile. Let's do this in a let. And then we're just going to return calling the predicate with the tile. Okay, that looks like the simplest thing that'll work. Cool. So that passed. We are not done yet, because I can imagine another file, or excuse me, another map that'll fail. So this test is going to be with first point false, others true. So now we need a special map to differentiate. So let's destructure the point. We'll return if x is 0, and we'll return rock. Otherwise, we'll return grass. And then our predicate is going to be tile equal to grass. So in this case, the first tile is rock. That one should return false. So I think this will fail the way we've implemented this so far. Cool. So now, here is how we actually need to implement this. We're going to check the first tile. And if that tile is true, then great, we found one. But if that tile is false, then we actually need to check the next tile and keep checking tiles until we get to the end of the map. So let's do a case statement. And if we get true, then we're done. We'll return true. If we get false, we need to recurse. So I think for this to work, we're going to need a helper function. So the way I think about recursion is we have these two coordinates that are going to need to change at each step in this recursion. I think we're going to need to define an extra helper function. So I think it'll look like this. So we'll want to have that helper pass the initial values to it. So I'm going to call my helper an E prime. We're going to pass the predicate, the map, and then the starting coordinate that we're going to check. And the helper basically going to be the same thing that we had, but it'll also take the point as a parameter. We'll pass that, or we'll use that, and then when we recurse, we'll pass a different point. All right, so then when we recurse, it's called n prime. Call any prime, same predicate, the same map, but with a new point. And specifically, we're going to increment the x value. All right, cool. So I think that passed the one test. However, we now have infinite recursion in another one of the tests, I'm guessing, because there's never a termination case. If we keep getting false, then it's going to keep failing. So we need to end this at some point. And what I'm going to do is say if point.x is greater than or equal to 10, then we'll return false and say we're done. Otherwise, we'll recurse. Cool, got it. So there's one more problem. Let's see, in the chat, Proton Gaming is asking if tail recursion is as fast as a for loop. So there is an optimization in the Elm 0.17 and later compiler, which will perform tail call optimization. Basically, when it detects a tail call recursion, it is going to compile it into a loop in the JavaScript code. So yes, if you do your recursion properly by putting the recursion always at the tail position, then the Elm compiler will optimize that for you. Meaning, and what that means, if you don't know, means that when we recurse, we're calling another function. So your stack is going to keep growing, and you'll be calling from within, and then you'll return all the way back out. But the optimization you can do is that if the very last statement of the recursive function is a call to that same function, then when you recurse, you don't actually have to remember where you came from because you were immediately going to return when you come back from the call you just went into anyway. So it can do an optimization where it just throws away the outer stack frame when you recurse, and then you don't have a lot of memory use for doing the recursion. Okay, I got slightly distracted, but I believe where we're at is we need to handle the y coordinates. I believe we'll have a failing test if all of the tiles in the first row are false, but the tiles in the second row is true. The first row false, others true. We're going to change this map to have the y coordinate. If y is 0, we'll return rock. Otherwise, we'll return grass. Whoops, forgot my comma. All right, I think this test will fail. Yep, and it does. So I believe all we have left to do is say that if we're done with this row, we want to jump to the next row. So I'll start by recursing in, and we'll go into the predicate, same map. Now our point is going to be x equals 0 and y equals point.y plus 1. I believe this won't terminate in certain cases. Yep, looks like it's going infinitely. So that just means we need one more if in here. And we'll say if point.y is greater than or equal to 10, then we will now finally return false. Otherwise, we will check the next row. Cool, and that passes. And I think we can refactor this slightly. Just check this first. So if the y point too big, we'll return false. Otherwise, we will check if we need to go to the next row. Otherwise, we will go to the next column in this row. Might have slightly worse performance to do that, but it looks a little nicer, so I'll leave that for now. All right. So I think we're at a commit point where we have written, let's add the type signature for any prime. There's a private function. Cool. So our test pass, our build looks like it's still building properly. Great. So let's commit this. So I just changed our demo. Then we need to git ignore our index node modules. And we can add the rest of the files. So let's see. We added our git ignore. We added our map module with this any utility. They added a tests git ignore file for us. Great. The test.main is the test runner. Wrote our tests for map. That looks good, and we have our map generation to do. There's our packages for the test. Okay. So we wrote map.any using some nice test-driven development. I'm going to push that up. All right. So, let's see. Been going about 45 minutes. Why don't we take a quick break? I'm just going to grab some water, so this will maybe be 3 minutes. Let's take a 3-minute break, and now when we come back, we will be ready to finish our first test for map generation. We can kind of get the skeleton of the map generation set up and hopefully convert that into a fuzz test or a property test. So I will see you back in a few minutes.